If you like the story, you can support the author on Patreon. Link is in the description.
Chapter 71, 3 Minds. Jake woke up first. He always did. Up. Both of you. He swung off his bunk and smacked the headboards of his brother's beds on the way down. Marcus groaned. Dean didn't move. Today's the 3-person test. Move. Marcus yawned wide enough to dislocate something. We've done dozens of these. It's routine. Dual connections are routine. This is the first triple. Different animal. Dean finally sat up, rubbing his face. Is this the part where you make us go running? Yes. Of course it is. Jake's coping mechanism for any high-stakes event was a 5-mile run. His brother's coping mechanism was complaining about Jake's coping mechanism. The dynamic had been this way since childhood. They ran the perimeter of the old radar station's athletic field. The new research center was visible through the fence, a massive crescent-shaped structure, steel-framed, 30 meters tall, with hangar-sized doors on its convex face. The building was nearly complete. Everyone at the facility had theories about what would go inside. The doors were sized for something very large. After the run and breakfast, the 3 brothers walked to the laboratory. The Sullivan and Peterson triplets were already there. Reeves and the senior team were running equipment checks. Ryan arrived a few minutes later, reading a report. The drift device sat in the center of the room, its sea urchin hub gleaming, reaction chambers filled and bubbling faintly, 3 sensor caps waiting on their articulated arms. Take a seat, Reeves told the pilots. Standard prep. You know the drill. Ryan settled into a corner with the data report. The 3-person test was scheduled for 10, and it was barely 9. He used the time to review Thornton's analysis of the plasma generation experiment. The cross-reference with the decade-old data was promising, core parameters aligned within acceptable margins, and several anomalies from the original tests could now be explained by the focusing lens theory. Cross approached Ryan with an idea. Before we start the triple connection, I'd like to run a secondary experiment. A memory test. Ryan looked up. What kind? We give each pilot a unique password in private. During the drift, we instruct them to deliberately recall the moment they received it. If the connected pilots can perceive the password through the shared memory fragments, it proves that directed recall can transmit specific information through the link. Ryan considered it. The drift's memory sharing had always been involuntary, fragments surfacing at random. Cross was proposing to test whether a pilot could intentionally push a specific memory into the shared space. Do it, Ryan said. Cross and his team moved quickly. 9 passwords, 1 per pilot, delivered individually in separate rooms. Simple words. Easy to remember. Easy to verify. At 9:55, a knock on the laboratory door. Ryan opened it. Patricia stood in the corridor, not crossing the threshold, positioning herself where she couldn't see inside. Quick heads up, she said quietly. Today's test is being observed remotely. Aegis leadership has access to the laboratory cameras. Ryan's eyebrows rose slightly. Leadership as in the division. Patricia cleared her throat. Leadership as in the top. The CEO. He cleared time specifically for this. Ryan understood. The 3-person drift was the milestone that determined whether the Jaeger concept was viable. If 3 minds could share one neural space, a 3-pilot mech became possible. The person who controlled Aegis's entire budget wanted to see it happen in real time. Also, Patricia added, after the experiment, come to my office. There's a call waiting for you. From whom? Patricia's expression said everything her words didn't. Just come. She left. Ryan returned to the lab, glanced briefly at the camera mounted in the upper corner of the room, and said nothing to the team. Let's begin. Jake, Marcus, and Dean took their positions. 3 chairs. 3 sensor caps. The brothers settled in with the easy familiarity of people who'd done this enough times to find the setup boring. The caps descended. Contact sensors found their positions. Signal amplifiers locked against temples. Neck cradles clicked into place. Ryan activated the drift device. The central hub's reaction chambers erupted into motion. Solutions cycling, foaming, shifting color. The signal processor's fans spun up. 3 green lights appeared on 3 sensor caps. 3 minds entered the same space. On the monitoring display, 3 virtual brain models appeared in a triangular formation, drifting slowly toward a central convergence point. The neural patterns in each brain were already beginning to synchronize, their oscillation frequencies pulling toward alignment like tuning forks finding the same pitch. Neural sync, 30%. The number climbed. Steady. Consistent. No rejection spikes. No instability. Asterisk 35%. 40%. 55%. Reeves watched the display without breathing. Three-person neural synchronization had never been achieved. Not by any lab, any institution, any researcher in the history of neuroscience. If this worked, the entire field's understanding of interbrain connectivity would have to be rewritten. Asterisk 70%. 80%. 90%. The three brain models were nearly overlapping now. Three separate neural architectures, converging into a unified pattern, their activity signatures becoming indistinguishable from one another. Asterisk 95%. 98%. 100%. The room exhaled. Full synchronization. Three human nervous systems, linked through the liquid neural connection device, sharing a single cognitive space. The display showed a single merged brain model where three had been, its activity pattern a synthesis of all three pilots' neural signatures. Holding, Reeves said. His voice was barely above a whisper. Sync is holding at 100%. Ryan checked the secondary metrics. Neural pressure, well within safe limits. Signal integrity, perfect. Connection stability, rock solid. The liquid neural system had been designed for three-person operation, and it was performing exactly as specified. Cross remembered his experiment. Pilots, please recall the moment you received your passwords. Focus on the memory deliberately. The three brothers, eyes closed, faces calm, followed the instruction. A pause. Then they opened their eyes, almost in unison. Well? Cross asked eagerly. Jake spoke first. I could feel them remembering something. Both of them. But the images were blurry. Like looking through frosted glass. I could tell there was a scene, a room, a person talking, but I couldn't read the password itself. Marcus and Dean confirmed the same experience. Directed recall worked. The other pilots perceived that a memory was being pushed into the shared space. But the resolution was too low for specific details. The password itself was invisible behind what Jake described as heavy pixelation. Cross was delighted anyway. The principle was proven. Directed memory transfer was possible through the drift. The current resolution was too low for practical information exchange, but with deeper psychological conditioning and longer connection durations, the fidelity might improve. The Sullivan and Peterson triplets followed. Both sets achieved full three-person synchronization. Both confirmed the directed memory findings. 3 tests. 3 full successes. The three-person drift was viable. Ryan didn't wait for the celebration to finish. He left Reeves and Cross to handle the post-test analysis and walked quickly to Patricia's office. The door was open. Patricia was standing beside her desk. On the desk sat a red telephone, receiver lifted, line open. Someone was already on the other end. Ryan sat down, picked up the phone, and said, "This is Ryan Mercer." Chapter 72, The Call. "Hello." Ryan picked up the red phone. The voice on the other end was warm but carried the unmistakable weight of someone accustomed to being the most powerful person in any room they entered. "Ryan. This is the first time we've spoken directly. I've been wanting to have this conversation for a while. Things have been busy on my end. Today I finally have the time." Ryan placed the voice immediately. He'd seen enough press conferences and Senate hearings to recognize it. The chairman of the board that oversaw Aegis Industrial's parent organization. The person who, in practical terms, controlled the largest defense industrial apparatus in the country. "I've been following your projects closely," the chairman continued. "I watched today's experiment on the laboratory cameras. No audio, unfortunately, but I could see the result. Three-person neural synchronization. Successful. All 3 triplet sets achieved full sync. The liquid neural connection system is performing at specification for 3-person operation. From here, it's a matter of training the pilots to sustain the connection for longer durations." Impressive. "I've always believed in the neural link program." A pause. Then the chairman's tone shifted from congratulatory to exploratory. "I wanted to ask you something. The neural link's potential for controlling non-humanoid machines. We've seen demonstrations of brain-computer interfaces being used to pilot drones abroad. Our own teams have attempted to adapt your scrapper system for unmanned aircraft, with mixed results. Ryan rubbed his chin. The neural link is most efficient when controlling a human-shaped machine. The pilot's own motor neuron pathways map directly to the mech's movements. The decoding is fast because the signal vocabulary matches the human body's vocabulary. The pilot can even use physical motion to reinforce the neural commands, which virtually eliminates decoding errors. Non-humanoid platforms are a different problem. Every action the aircraft needs to perform, engine ignition, weapon deployment, flight surface adjustments, has to be mapped to a different neural signal. An aircraft has dozens of discrete control functions, each requiring its own neural command pathway. Building that mapping is a massive systems engineering challenge. Is it something you'd be willing to pursue? Ryan considered. Not at this time. My current project load is at capacity. The three-person drift is where I want to focus. The chairman didn't sound surprised. The drift is successful. What's your next step? I want to build a large-scale mechanical arm. A single limb, scaled to Jaeger proportions, connected to the drift system. The purpose is to test the maximum neural pressure that human pilots can sustain when linked to a machine of that size. It's the critical unknown. We know the drift works between people. We know the neural link works between a person and a small mech. We don't know what happens when three connected minds try to drive something 250 feet tall. The line was quiet for a moment. The Jaeger, the chairman said. Crimson Typhoon. Yes. Another pause. Longer this time. Ryan, we've evaluated your Jaeger proposal thoroughly. Multiple review cycles. The technologies in your outline are genuinely visionary. The plasma cannon, the drift system, the reactor design, all of it represents potential breakthroughs across multiple domains. But building a 250-foot combat mech for $20 billion is, by any rational assessment, an enormous gamble. Our analysts believe the actual cost could be significantly higher. And once a project of that scale begins, the sunk cost dynamics make it extremely difficult to stop, even if the results aren't materializing. Ryan had expected this. The chairman's concerns were legitimate. $20 billion was a staggering commitment, and the people responsible for that money had careers, reputations, and institutional credibility on the line. Our preferred approach, the chairman continued, is to extract the individual technologies from your proposal and develop them separately, in their respective fields, at a manageable pace. The plasma cannon is already underway. The neural link has commercial applications through your prosthetics venture. The reactor technology is being scaled for industrial use. Each of these can be validated independently, at lower cost, with lower risk. That approach would take decades, Ryan said. You're 14 years old. You have decades. The technologies don't work in isolation. I've explained this before. The first principles problem. You can't understand a component by studying it outside its system. You have to build the system to understand the component. Crimson Typhoon isn't a vanity project. It's a laboratory. The only laboratory that can teach us how these technologies actually interact under real-world conditions. I understand the argument. But $20 billion for a laboratory is a hard sell, even with your track record. Ryan knew this was the moment. The chairman had called him personally. Had watched the three-person drift in real time. Was still on the line, still listening, still open. If Ryan couldn't make the case now, he might not get another chance at this level. Sir, may I explain why I believe Crimson Typhoon matters beyond the technology? Go ahead. Ryan straightened in his chair. Building Crimson Typhoon isn't just a scientific endeavor. It's an economic and cultural one. The chairman's posture changed. Ryan couldn't see it, but he could hear it in the quality of the silence. The man was listening differently now. Every major technology platform in history has generated economic value that dwarfed its development cost. The Internet. GPS. Semiconductor fabrication. The initial investment looked insane at the time. The returns made the investment look trivial in retrospect. Crimson Typhoon contains over 1,000 discrete technologies. Each one has potential applications outside the mech itself. The plasma cannon alone justifies the weapons research budget. The drift system has implications for coordinated operations across every branch of the military. The reactor design could transform the energy sector. The materials science required for the airframe will advance every industry that uses high-performance alloys. But those technologies can be developed separately, the chairman interjected. They can be developed separately and understood poorly. Or they can be developed together, inside the system they were designed for, and understood completely. The difference isn't just speed. It's depth. When you build the complete machine, you discover interactions between components that you could never predict from studying them in isolation. Those discoveries are where the real breakthroughs come from. Ryan paused. Then he played his strongest card. And there's the cultural dimension. Crimson Typhoon wouldn't just be a machine. It would be a statement. The most advanced piece of engineering ever constructed by human hands, built here, by our people, with our technology. The global attention would be unprecedented. The talent it would attract, the partnerships it would enable, the industries it would spawn. We're not just building a mech. We're building a symbol of what this country can achieve when it decides to reach for something extraordinary. The line was silent for a long time. You make a compelling case, the chairman said finally. I'm not going to approve $20 billion on a phone call. But I'm going to authorize the next phase. Build your test arm. Prove that the drift can control a Jaeger scale system. If that works, we'll have a very different conversation about full construction. That's all I'm asking for. For now. For now, Ryan agreed. The chairman chuckled. You remind me of someone. I can't decide if that's reassuring or terrifying. Hopefully both, sir. Good night, Ryan. Good night. The line went dead. Ryan set the receiver down on the red phone and sat in Patricia's empty office for a long time, thinking. The test arm was approved. The next domino in the chain. Build the arm. Prove the drift works at scale. Then make the case for Crimson Typhoon with data instead of words. One step at a time. One piece at a time. The Jaeger was coming. Chapter 73, The Pitch. Ryan settled into the chair and found his rhythm. Mechs have a unique property that no other technology platform shares, he said. They're inherently spectacular. A 250-foot humanoid machine standing in the ocean is something that every human being on the planet would stop and look at. It's visceral. It's primal. It bypasses analysis and goes straight to the gut. When I live-streamed Scrapper's untethered test, 10 million people watched in real time. Not because they understood the plasma reactor or the neural link or the energy distribution architecture. Because a giant robot ran through a fence. That's it. That's the entire appeal. It moved, and it was huge, and people lost their minds. If I'd live-streamed a battery test instead, showing the same plasma reactor technology in a lab setting, do you know what would have happened? The chairman thought about it. Nothing. Exactly. Nobody watches battery demonstrations. Nobody shares them. Nobody talks about them at dinner. But a mech? A mech is front-page news in every country on Earth. The technology inside it could be identical, and the public response would be completely different. That's the cultural argument for Crimson Typhoon. It's not just a laboratory. It's a landmark. The most visible, most talked about piece of engineering ever built. And every conversation about it, every news segment, every tourist who comes to see it, every kid who puts a poster of it on their wall, that's attention. That's influence. That's soft power. The chairman was listening carefully now. This wasn't the usual pitch. This wasn't fund my research because the science is important. This was fund my research because the product will reshape how the world sees us. Our facility is on the coast, Ryan continued. The barrier islands are less than 20 miles offshore. If Crimson Typhoon is built and tested here, it will be visible from those islands with the naked eye. You can't hide a 250-foot machine. Satellite imagery will detect it within hours of its first outdoor appearance. So why try to hide it? Make it a feature, not a liability. The islands already have tourism infrastructure. A Jaeger standing in the ocean within visual range turns them into the most visited destination in the country overnight. The economic impact on the surrounding region would be measured in billions annually. And the security implications of foreign observation? Minimal. Crimson Typhoon has an armored exterior. Foreign intelligence can photograph it, measure it, estimate its weight and speed. They'll learn its dimensions and its gait pattern. None of which tells them anything about the technologies inside, the drift system, the reactor design, the plasma cannon, the neural architecture. The exterior is a shell. The value is internal. Ryan paused for effect. We could even use it for strategic misdirection. Publicly demonstrate capabilities that suggest one thing while the actual specifications are something else entirely. Let foreign analysts build their models around what they can see. They'll be wrong, and they won't know it. The chairman was quiet for a moment. You're proposing to use a 250-foot robot as a tourism attraction and a disinformation platform. I'm proposing to use it as a technology laboratory that also happens to be a tourism attraction and a disinformation platform. 3 birds, one very large stone. A pause. Then a sound that might have been a chuckle suppressed into a cough. You make an interesting case. But you haven't addressed the fundamental risk. If the project fails, if Crimson Typhoon can't be built, none of the secondary benefits materialize, and we're left with a $20 billion hole. Ryan glanced at his system panel. Project 2, 67%. In less than 6 months since Scrapper's completion, the system had unlocked more than 2/3 of Crimson Typhoon's technology base. At this rate, the remaining technologies would be available within months. The engineering wasn't speculative. It was inevitable. But he couldn't explain that. Give me more time, Ryan said. I'll deliver results that make the risk assessment irrelevant. The chairman seemed to recognize that Ryan had reached the limit of what he could promise without revealing something he wasn't willing to share. The conversation pivoted. Let's discuss your energy systems. Ryan knew this was coming. The real business. We've completed preliminary testing of your plasma reactor and ion battery technologies in military applications, the chairman said. His voice had lost its casual warmth. This was the institutional voice. The voice that moved budgets and shaped policy. A single ion battery can power a main battle tank for approximately 20 miles of continuous operation. If the plasma reactor is used as the primary power source, that range extends to 50 miles. With no combustion, no exhaust signature, no thermal footprint detectable by conventional surveillance. The chairman let those numbers sit in the silence. What you've invented isn't an energy system, Ryan. It's a strategic weapon. An oil economy killer. If these technologies reach commercial scale, the global energy market restructures overnight. Oil-dependent economies collapse. Petrodollar alliances fracture. Supply chains that have been stable for 70 years disintegrate. I'm aware of the implications. Then you understand why we're asking you to hold off. The reactor and battery patents are yours, per the terms of our agreement. You have the legal right to license them commercially at any time. We're asking you, as a matter of strategic coordination, not to enter the energy market until we've developed a deployment framework that manages the transition. What's the timeline? Years, not months. Possibly a decade. We need to position our own energy infrastructure, negotiate with allies, prepare contingencies for the economic disruption. If the transition happens too fast, it destabilizes everything. Including us. Ryan understood. He'd always known the reactor and battery patents were too powerful to deploy casually. An energy technology that made oil obsolete wasn't just a product. It was a geopolitical event. Dropping it into the market without preparation would be like detonating a bomb in the global economy. I'll cooperate, Ryan said. On one condition. Name it. Invest the compensation in the Crimson Typhoon project. A long silence. Those are separate matters. We can't tie energy policy to mech construction. Ryan had expected the rejection. He had a backup. Then grant Prism Sciences a full tax exemption for the duration of the hold period. As long as I'm sitting on those patents without monetizing them, my company operates tax-free. A shorter silence this time. That we can do. Then we have a deal. We have a deal. The chairman's tone carried the faint bemusement of someone who'd just been negotiated into a corner by a teenager. Is there anything else? Not tonight. Then good night, Ryan. And congratulations on today's experiment. 3 minds in one space. That's something that's never been done before. Thank you, sir. Good night. The line went dead. Ryan set the phone down and sat in the quiet office. Through the window, the ocean was a dark line against a darker sky. Somewhere out there, 20 miles offshore, the barrier islands sat in the dark. Empty beaches. Quiet harbors. Small hotels with vacancy signs. They had no idea what was coming. Chapter 74, Progress. Ryan hung up the red phone and walked out of Patricia's office. She was waiting in the corridor. How did it go? Got what I needed. Ryan stretched. More or less. Patricia raised a hand before he could elaborate. Don't tell me details I'm not cleared to hear. If everything's fine, go get some rest. Ryan smirked and left. He'd barely reached his quarters when he found Kyle standing outside the door. I'm here for the reports, Kyle said, waving awkwardly. Right. Ryan had forgotten. A few pages of the firefighting mech component reviews were still unfinished. He let Kyle in, sat at his desk, and opened the files. After spending weeks immersed in Crimson Typhoon's specifications, reviewing scrapper-based modifications felt like grading elementary school homework after reading a doctoral thesis. The first-generation mech's design had been clever for its scale, but compared to a fourth-generation Jaeger, every system was crude, every structure was oversimplified, every engineering decision was a compromise that a larger platform wouldn't need to make. How's the firefighting mech coming along? Ryan asked while he worked. The professors finalized the structural framework. We've built a physical scale model and several structural test components. Right now we're running performance tests and iterating on the design. Kyle paused to organize his thoughts. Current spec has the mech at about 30 feet tall, under 100 tons fully loaded with the fire suppression system. Light enough to be transported by heavy haul trailer to the deployment zone. That's fast progress. Kyle scratched his head. Fast and expensive. We've burned through most of the 10 million Callaway allocated. The professors have been hounding him for more funding. Apparently he's been having headaches. Ryan laughed. Callaway's headaches were a recurring theme. The firefighting mech was now officially MIT's project, which meant MIT's budget, which meant Callaway's problem. Ryan could build a mech skeleton for $250,000 because the system gave him perfect blueprints with zero wasted effort. Kyle's team had no system. They had to test every structural concept, fabricate every prototype component, run every simulation manually, and iterate through dozens of failed designs before finding the right one. That process cost money. Real money. Keep pushing, Ryan said, finishing the last annotation. Once the firefighting mech produces results, your team will have earned enough experience to attempt an original design. That's the real milestone. Kyle looked uncertain. We're still completely dependent on Scrapper's transmission model. We can't seem to get past it. Scrapper's transmission design is actually straightforward. With enough experimental testing, you'll internalize the principles. Designing something new on top of that will come with time. Kyle's expression suggested he did not find Scrapper's transmission design straightforward, but he took the hard drives and left without arguing. Alone, Ryan opened the system panel. 68%. The progress had ticked forward during the phone call. New data had been released, Crimson Typhoon's shock absorption and balance systems. The highlights were the Achilles dampeners in the feet and the magnetorheological dampers in the leg joints. Together, they formed a dual-layer vibration absorption system that could neutralize the kinetic feedback from a 1,700-ton machine running at full speed. This was the system that let Crimson Typhoon do things no other Jaeger could: sprint, pivot, and perform acrobatic maneuvers that would shake a lesser machine apart. The balance system wasn't just good. It was the best in the entire Pacific Rim universe. Ryan wanted to study it immediately. Forced himself to look away. Not yet. The priority was the test arm. He opened a different section of the system's database, Crimson Typhoon's arm specifications. 3 arms. 1 left, 2 right. The right arms were thinner, lighter, and structurally simpler than the left. Perfect candidates for the first physical construction. Ryan chose the forward right arm. Stripped of external armor, it weighed approximately 70 tons. Diesel piston driven. The wrist housed retractable hardened alloy saw blades that could extend and spin at combat speeds. The shoulder joint connected to a dorsal thruster assembly that could rotate the upper body, adding centrifugal force to the arm's striking power. Compared to the reactor systems, the drift architecture, or the plasma cannon, the right arm was mechanically simple. Drive system and weapon system. 2 challenges, both well within Ryan's current capabilities. He began transcribing the blueprints into his CAD software, translating the system's specifications into fabrication-ready drawings. As he worked, he made modifications. The arm needed to function independently of the main body's power and drive systems, since it would be tested as a standalone unit before being integrated into the complete mech. An auxiliary power connection. Independent hydraulic lines. A self-contained control interface that could accept drift input from the liquid neural connection device. The work absorbed him completely. Hours passed. The sky outside his window darkened from blue to black to the starless grey of coastal overcast. His phone shattered the silence. Mason Reed. Ryan picked up. What's going on? Mason's voice was tight. Not panicked, but stressed. We've got a problem. Someone's coming after us. Coming after you how? Not physically. Publicly. A competitor just released a video. Their prosthetic is better than ours, and they're making sure everyone knows it. Ryan sat back in his chair. Who? Some company I've never heard of. Neuropath Technologies. Harvard affiliated. They've got a brain-controlled arm that makes our prototype look like a toy. And their video just went viral. Chapter 75, that's it. Mason was talking fast. Multiple labs just released their own neural prosthetic demos. Professional-looking videos. Clean labs, proper lighting, expert commentary. Their technology looks way ahead of ours. The hottest one is Neuropath Technologies. They've been riding our wave since day one, and now their video is everywhere. Ryan's response was a single syllable. You need to see it, Mason insisted. Ryan opened his laptop and searched for Neuropath Technologies. The video was the top result. He clicked play. The difference in production quality was immediately obvious. Neuropath's video was shot in a proper laboratory, bright, organized, gleaming equipment arranged with the careful aesthetic of a company that knew investors would be watching. Researchers in lab coats stood at designated stations. A presenter walked viewers through the technology with clear, accessible explanations. Graphics illustrated the neural signal acquisition process. The volunteer's prosthetic arm moved with visible precision. It looked professional. It looked impressive. It looked like exactly the kind of video that would make people think Ryan's shaky, out of focus, static camera test footage was amateurish by comparison. The comments confirmed it. This looks way more advanced than what Ryan Mercer showed. Incredible technology. Is this the same as what Mercer is doing? For the first time, it looks like someone might actually be ahead of him. Ryan watched the entire video. Studied the technical explanations. Noted the signal acquisition methodology, the decoding approach, the motor command vocabulary, the response latency. When it ended, he said 2 words. That's it. What? Mason's voice cracked on the other end of the line. What do you want to do about this, exactly? Ryan asked. Mason sputtered. The competitor had a better-looking video, a better-funded lab, a Harvard-trained founder, and technology that appeared to outperform Prism Science's prototype on every visible metric. What could they do? Storm Neuropath's offices? Issue a press release? Start a Twitter war? Should we make a statement? A response. No. Too much effort. Keep working on the arm. Improve the drive system. Hit the response time targets I gave you. Mason's scalp tingled. He could feel individual hairs abandoning ship. That's the plan? Just keep working. That's always the plan. What Neuropath showed is targeted muscle reinnervation paired with surface EMG acquisition. It's the same approach that every top lab in the world uses. Their video looks impressive because they have a nice lab and a good cameraman. The underlying technology is competent but conventional. Ryan paused. Our technology isn't conventional. When it's ready, nobody will be making comparisons. Mason wanted to believe this. He also wanted to not lose all his hair before turning 25. Okay, he said. We'll keep working. He hung up. Ryan closed the Neuropath video and returned to the Crimson Typhoon arm blueprints without a second thought. Meanwhile, Dr. James Alcott was sitting under studio lights. The show was called Tech Spotlight, a nightly program that chased trending topics and brought in expert guests for live commentary. Tonight's topic, brain-computer interfaces and the neural prosthetics boom. The guest, the Harvard-educated founder of Neuropath Technologies, whose demonstration video had just crossed 5 million views. The host, a woman with sharp eyes and a warm delivery, introduced the segment. A few days ago, Ryan Mercer, the teenage inventor known for his mech scrapper, released a video showing what he called a neural prosthetic prototype. The footage went viral. But tonight, we're hearing from another researcher who says this technology has existed for years. She turned to Alcott. Dr. Alcott, welcome. Alcott was polished. Confident. He explained the technology clearly, walked the audience through Neuropath's demonstration, and positioned his company as the established expert in a field that Ryan Mercer had merely entered. He was careful not to attack Ryan directly. Instead, he framed the narrative as the public is just now discovering something that scientists have been working on for decades. The implication was clear: Ryan was a newcomer in a field where Neuropath had years of expertise. It was smart positioning. And it was working. The live chat was full of people expressing surprise that the technology predated Ryan's video. At the film school, Chloe's roommate Becca was watching Tech Spotlight on her laptop when something caught her eye. The background screen behind the host was playing Ryan's prosthetic video. The one with the bad lighting, the static camera, and the out-of-focus faces. Becca stared at the screen. Then stared harder. Then minimized the live stream and searched for the original video. She found it. Played 30 seconds. The quality. The color grading. The complete absence of any camera movement. She'd seen this exact footage before. On Chloe's laptop. When Chloe had claimed she was practicing her editing skills. Becca pulled up the video. Checked the upload account. Ryan Mercer's official channel. Chloe had edited Ryan Mercer's video. Chloe, her roommate, the quiet girl who ate fried chicken drumsticks and went running every morning, had a direct working relationship with the most famous teenager in the country. And she'd lied about it. When Chloe returned from her evening jog, she opened the dorm room door to find 3 roommates seated in a row, arms crossed, expressions dangerous. "Chloe," Becca said. "Explain." "Explain what?" Becca held up her phone. Ryan's prosthetic video, playing on loop. "You told me this was a practice edit. A student exercise. And now it's on national television being discussed by a Harvard researcher. Would you like to revise your statement?" The other 2 roommates flanked Becca. "What's your relationship with Ryan Mercer?" "Spill. We have ways of making you talk." Chloe assessed the tactical situation. 3 adversaries, positioned between her and her bed, blocking the path to her snack drawer. Hostile intent confirmed. She reached over and flipped the light switch. The room went dark. 3 seconds of muffled sounds. When the lights came back on, all 3 roommates were on the floor in various states of defeat, and Chloe was sitting on her bed, drumstick in hand, looking serene. "He's my childhood friend," she said calmly. "I've been editing his videos since before any of you knew his name. And if you ever try to ambush me again, the lights stay off longer." "Yes, ma'am." "Understood. We love you, Chloe." Chapter 76, Across the Ocean. Chloe found out about the situation through her roommates, who found out about it through the internet, which had found out about it through an escalating chain of competitive one-upmanship that Ryan hadn't noticed because he was designing a 70-ton robot arm. The Neuropath video had been the first salvo. But it wasn't the last. Someone had reposted a video from abroad. The Whitfield Neuroscience Laboratory at Harvard, in collaboration with a major broadcast network, had released a full documentary-style segment on their brain-controlled prosthetic research. The production quality was in a different universe from Ryan's shaky footage. Professional cameras, cinematic lighting, narrative structure. It opened with an interview with Jennifer, Whitfield's long-term volunteer. "5 years ago, I was in a car accident on my way to work. A vehicle ran a red light and hit me head-on. After 30 surgeries over the course of a month, my right forearm was amputated. During the same procedures, the nerves from my amputated arm were transplanted to the remaining tissue, which allows me to control a prosthetic with my brain. And when I wear the prosthetic, I can feel things again. Pressure. Temperature. The sensation of touch." The video showed Jennifer operating a prosthetic hand with individual finger control, picking up objects of different sizes, adjusting grip pressure in real time. The hand responded to her thoughts with minimal latency. And according to the narration, sensory feedback electrodes in the prosthetic sent signals back through the transplanted nerves, giving Jennifer a limited but real sense of touch. It was, by any conventional measure, more advanced than what Prism Sciences had demonstrated. The internet responded accordingly. "This makes Ryan's prototype look like a student project. Harvard has been doing this for years. The kid just walked into a field where the adults have decades of experience. He should stick to mechs. This isn't his arena. For the first time, I'm seeing real competition. And the competition is winning." Chloe watched the Harvard video, read the comments, and called Ryan. Hey! Are you busy? Always. Have you seen the latest? It's not just neuropath anymore. Harvard released a video. Their prosthetic has tactile feedback. The user can feel things. Interesting. I'll look at it when I have time. He sounded exactly as unbothered as he had when Mason called about neuropath. Chloe decided not to push it. Other topic. My birthday's coming up. If you have time, come visit. Ryan checked the calendar. November 21st. He'd be turning 15. It was close. Deal. I'll make time. You better. I'll plan dinner. They talked for a few more minutes about nothing in particular, the kind of conversation that existed mainly to confirm that the other person was still there, still okay, still connected across the distance. After they hung up, Chloe turned around to find all three of her roommates pressed against the door frame, eavesdropping with zero subtlety. She gave them a look that could have frozen seawater. They scattered. Harvard. The Whitfield Lab. Professor Whitfield was watching Jennifer run through her standard test routine while a graduate student logged data on a laptop nearby. The experiment was proceeding normally. Jennifer's prosthetic hand picked up a foam ball, a metal cylinder, a glass of water. Each object held, manipulated, set down. Her face showed the concentrated focus of someone performing a task that was simultaneously mundane and miraculous. Osman sat beside Whitfield, a paper cup of coffee in his hand. You could at least have taken me to a cafe, Osman said, sipping. This is instant coffee. From a jar. In a paper cup. I helped you become an international sensation and you're serving me powder in hot water. Whitfield laughed. Instant coffee has character. It has the character of a parking garage. Osman pulled out his phone. Have you seen the comments? People are calling you the pride of the scientific community. They're saying you've humbled the mech kid. He read one aloud, translating the sentiment. Professor Whitfield has shown the world what real neuroscience looks like. Ryan Mercer should take notes. There are thousands of these. Whitfield shrugged. He wasn't interested in internet approval. He was interested in Jennifer's grip pressure data, which was trending in the right direction. If I hadn't brought the network cameras in, none of this would have happened, Osman continued. You'd still be sitting in this lab, invisible, begging Harvard for table scraps. I deserve dinner at a restaurant with actual silverware. When I get new funding, I'll take you somewhere nice. I'll believe it when I see a menu. Whitfield's phone buzzed. He glanced at the screen. Unknown number. He almost dismissed it, then noticed the area code. He answered. The voice on the other end was professional, direct, and represented a company whose name made Whitfield sit up straight. Dr. Whitfield, this is the Helios Group. We've been following your work with great interest, and we'd like to discuss a potential investment partnership. Whitfield muted the phone and looked at Osman. Helios Group, he whispered. Osman's eyebrows shot up. Helios Group was one of the largest technology investment firms in the world. They had stakes in electric vehicles, artificial intelligence, space technology, and advanced manufacturing. Their involvement didn't mean money. It meant scale. Resources that Harvard's grant system could never match. Manufacturing capacity. Distribution networks. The difference between a laboratory prototype and a product on the market. Whitfield unmuted the phone and spent 10 minutes in the most pleasant professional conversation he'd had in years. By the end, a meeting was scheduled for the following week. He hung up and raised his paper cup. Cheers. Osman clinked his own cup against it, grinning. Cheers. But I'm still expecting that restaurant. Chapter 77, Assembled. Ryan said he'd watch the Harvard video when he had time. He did not have time. The day after checking the Crimson Typhoon arm blueprints, he walked into Patricia's office and submitted the fabrication order. When Patricia heard that the component weighed 70 tons and was a single arm for a machine that didn't exist yet, she nearly spit out her water. But the order went up the chain, and the chain said yes. The following 2 weeks were a blur. Ryan shuttled between the two research facilities daily. The plasma cannon project needed his attention as the team prepared for assembly. The drift experiments needed oversight, the three-person connection durations had dropped to 20 minutes after the initial tests, and the pilots needed coaching to push past the plateau. The firefighting mech team kept sending Kyle with questions that only Ryan could answer. Mason's prosthetics team called twice a week for guidance on drive system modifications. He slept 6 hours a night and worked the other 18. Then, on a Tuesday morning, Patricia called. The plasma cannon components are here. All of them. Ryan was out of bed, dressed, and walking toward the weapons lab before she finished the sentence. He skipped breakfast. The parts had been ordered weeks ago, timed to arrive after Ryan had absorbed enough of Thornton's archived data to understand the underlying physics. The timing was perfect. He'd completed his theoretical study of the cannon's design principles. Now he needed to build the thing and test whether theory survived contact with reality. The weapons lab was packed. Thornton's entire team was present, 40 people crowded around the firing platform, watching the technicians unpack crates and organize components on the floor. "Morning," Thornton said, reaching down to clap Ryan on the shoulder. The height difference made the gesture look like a father greeting a child, which was visually accurate and professionally backwards. The components were spread across the concrete floor in ordered groups. The transmission coils, rings of superconducting material shaped like cross-sections of star fruit, each one designed to accelerate the plasma bolt through the bore at tremendous speed. A stack of them, progressively sized, ready to be installed in sequence along the barrel's length. The flange ring, a massive metal disc that would lock the muzzle assembly in place, providing structural stability for the focusing lens system. 3 focusing lenses, the critical components. Symmetrically shaped, precision machined to tolerances measured in microns, each one designed to concentrate and energize the plasma bolt at the instant of discharge. When installed, they would encircle the muzzle like the talons of a mechanical claw. On Crimson Typhoon, these would be the 3 prongs of the left arm's weapon hand. Various sub-assemblies had been pre-integrated at the factory, reducing the number of loose fasteners on the floor. But the installation was still complex enough that the technical crew spent over an hour studying the assembly diagrams before touching a single bolt. Ryan retreated to the control room and reviewed the data from the 4 successful plasma generation tests. All clean. All consistent. The generation chamber produced plasma reliably, heated it to target temperature without instability, and shut down safely every time. The generation system worked. The question was whether everything downstream of it, the transmission bore, the acceleration coils, the focusing lenses, the amplifier, would work too. Assembly took days. The technicians worked methodically, following the diagram step by step, verifying each connection before moving to the next. Thornton supervised personally, cross-referencing every installation against his own calculations. Ryan checked in twice daily, reviewing progress and flagging any deviation from specification. When the last component locked into place, Ryan returned to the lab. The plasma cannon stood on its firing platform. It was larger than he'd expected in person. The red armor cladding covered the barrel in 2 sections, upper and lower, designed to separate at the elbow joint during firing to vent waste heat. Massive bolts secured the armor to the barrel structure, visible from outside, industrial and unadorned. At the rear, the plasma generation chamber, its disc shape now integrated into the cannon's base, feeding directly into the transmission bore. Along the barrel, the acceleration coils, invisible inside the armored housing, stacked in sequence, waiting to hurl superheated plasma forward at velocities that would make a rifle bullet look stationary. At the muzzle, the 3 focusing lenses, arranged in a triangular pattern around the bore exit, each one angled inward, ready to concentrate the plasma bolt at the moment of discharge. The flange ring held them in position, and at the center of the ring, the retractable muzzle aperture waited. This was where the plasma would emerge. This was where theory became reality. Ryan had stripped 2 systems from the original design. The biological skeleton scanner, which targeted kaiju bone structures in the film universe, was useless in reality. And the mechanism that converted the focusing lenses into spinning blade weapons had been removed. The lenses were too valuable and too precisely calibrated to be used as melee armaments. Thornton's team spent the rest of the day running manual inspections. Every bolt, every seal, every electrical connection, every alignment measurement. Then a software diagnostic sweep, checking every sensor, every actuator, every safety interlock. By 8 p.m., the inspection was complete. No faults found. Thornton wiped his forehead. It's late. Do we wait until morning? Ryan considered. Then, we fire tonight. I don't want to give Murphy's Law overnight to find something we missed. He walked to the far end of the lab and pressed the door control. The seaward doors opened onto a tunnel. 3 kilometers long. Straight as a laser beam. Concrete lined, with overhead lights mounted at intervals. The lights activated in sequence, each one illuminating another 50 meters of corridor, the chain of illumination stretching away from the lab into the distance until the individual lights were indistinguishable from stars. Distance markers on the walls. 50 meters. 100. 500. 1000. 2000. 3000 meters. The cannon's maximum effective range. And positioned along the tunnel's length, at measured intervals, a series of targets. Concrete blocks. Steel plates. Composite armor panels. Each one waiting in the light, motionless, about to learn what 2000 degrees felt like. Chapter 78, First Shot. Outside the lab, a security detail was patrolling the perimeter. Inside, the test chamber was sealed. The ventilation system was running, ready to clear steam and heat the moment the cannon discharged. Everyone was in the control room. 40 researchers, the technical crew, and Ryan, all standing behind the blast-rated observation window, looking at the plasma cannon on its firing platform. Red armor. Exposed bolts. 3 focusing lenses arranged like talons around the muzzle. The generation chamber at the rear, dormant, waiting. Begin, Ryan said. He stepped into the security alcove at the back of the control room, entered the authorization code into the restricted terminal, and unlocked the cannon's firing system. The weapon required a 2-key activation sequence. Ryan held one key. Thornton held the other. Nobody else in the facility had access. The main console's display came alive. Thornton was already at the station, monitoring the system initialization. Unlocked. All systems nominal, Thornton confirmed. Ryan emerged and walked to the console. Every pair of eyes in the room followed him. Before touching the controls, he opened a supply crate and pulled out a stack of tinted safety glasses. Put these on. The discharge produces intense light. Standard eye protection won't be sufficient. The glasses were distributed. 40 people stood in a row behind the observation window, each one wearing dark-tinted lenses, looking like the world's most anxious audience at a 3D movie. Ryan entered the test parameters. Plasma temperature, 2,700 degree F. Charge duration, 3 seconds. Rounds, 1. Conservative settings. The cannon's maximum charge time was 6.7 seconds, beyond which the system entered overload and risked plasma leaking through the transmission bore. For the first test, Ryan wanted to confirm that the weapon worked at all, not push it to its limits. Glasses on. Secure. He confirmed everyone was ready. Then he pressed the firing command. The cannon responded instantly. At the muzzle, the 3 focusing lenses extended outward on their actuator arms, spread wide like opening fingers. The flange ring rotated, positioning each lens at its optimal angle. Then the lenses retracted inward, pulling tight around the bore exit, and the central muzzle aperture slid open. Electricity arced between the focusing lenses. Blue-white sparks jumped from prong to prong, converging on the open aperture, building in intensity. The sound was a low, compressive hum that pressed against the chest like a hand. Simultaneously, the firing platform elevated the cannon's barrel, lifting the weapon off its rail mount, suspending it in a firing position. The recoil dampeners engaged, bracing for the discharge. At the rear of the cannon, the armor cladding cracked open. The upper and lower plates separated at the barrel's midpoint, rising away from each other like wings, venting a blast of superheated air from the exposed transmission bore. The acceleration coils were visible inside, rings of superconducting material wrapped around the bore channel, each one flickering with contained electrical discharge, jumping and dancing like trapped lightning. The sound in the control room was indescribable. A rising pressure. A vibration that bypassed the ears and went directly into the bones. 3 seconds. In the generation chamber, the plasma reached target temperature. The system released it into the transmission bore. The acceleration coils fired in sequence, each one adding velocity, each one pushing the superheated mass faster and faster toward the muzzle. The plasma bolt reached the exit point. The focusing lenses contracted one final time. The aperture sealed and reopened in a microsecond pulse that compressed the bolt to maximum density. The amplifier fired. And the cannon spoke. A beam of light erupted from the muzzle with a force that made the entire building shudder. The observation window flared white. Even through the tinted glasses, the flash was blinding. A crack of thunder followed, not the rolling kind but the sharp, percussive kind, the sound of air being torn apart and slammed back together. The firing platform absorbed the recoil. The rail-mounted base skidded backward 6 inches on its track before the dampeners caught it and held. Then silence. The control room was still. Ryan looked at the display. Discharge, successful. We have a successful firing, he said. The room erupted. Cheering. Clapping. Someone was shouting. Someone else was laughing. Thornton was standing motionless, swaying slightly, as if the ground had moved under him and hadn't told him it was done. He looked at the cannon through the window. Steam was rising from the barrel as the internal cooling system purged waste heat. The armor plates slowly closed, sealing the transmission bore. The focusing lenses retracted to their resting position. The cannon had fired. Once. At conservative settings. With 3 seconds of charge instead of the maximum 6.7. And it had worked perfectly. Thornton caught the eyes of his veteran researchers. The ones who'd been with him a decade ago. The ones who'd spent 4 years trying to solve the problem that had just been solved in front of them. They looked back at him with expressions that mixed disbelief, vindication, and something that might have been grief for all the years they'd spent on the wrong side of the answer. Ryan waited for the chamber temperature to normalize, then led the inspection team into the test tunnel. The first target had been positioned at 100 feet. It was gone. Not destroyed. Gone. A scatter of charcoal black residue on the tunnel floor was the only evidence it had existed. The concrete block had been vaporized so completely that the fragments couldn't be identified without chemical analysis. Behind it, at 130 feet, a wall of steel plates. Same result. Slag. Residue. Nothing recognizable. At 200 feet, a panel of composite armor, 64 mm thick. The bolt had punched through it cleanly, leaving a fist-sized hole with glowing edges. The armor had survived, barely, only because the plasma had already lost significant energy passing through 2 previous targets. Further down the tunnel, the damage diminished progressively. By the 5th target, the bolt had lost enough energy that it only managed to burn shallow craters into the surface without penetrating. The tunnel walls told their own story. At the first target position, the impact had scattered plasma in every direction. Sections of the concrete lining were scorched black. One area had been melted through entirely and would need repair. An overhead light fixture at the 100-foot mark had taken a direct hit from a deflected plasma fragment and been reduced to a blackened skeleton of twisted metal. Ryan walked the full length of the damage zone, examining each target, each wall scar, each data point. 3 seconds of charge. 2,700 degrees. 1 shot. The cannon could fire 8 consecutive rounds before reaching its operational limit. It could charge for more than twice as long, at higher temperatures, with more energy behind each bolt. This had been a whisper. Nobody in the tunnel said a word. They didn't need to. The evidence was on the walls, on the floor, in the empty spaces where solid objects had been standing 30 minutes ago. Ryan turned to Thornton, who was crouching beside the remains of the first target, running his fingers through the residue. 10 years, Thornton said quietly. He held up his blackened fingertips. 10 years I tried to make this work. And here it is. He stood up. Dusted off his hands. Looked at Ryan with an expression that contained everything he couldn't say and didn't need to. Congratulations, Dr. Thornton. Congratulations yourself. They walked back to the control room together, leaving the cannon cooling in the dark behind them. Chapter 79, Report. 430 Advanced/Early Chapters, patreon.com/automxd. The plasma cannon didn't just burn. It hit. The bolt carried kinetic energy as well as thermal. In the films, a direct hit from Crimson Typhoon's cannon could stagger a 1,000-ton kaiju, knock it backward, send it reeling. The physics worked in reality too. Superheated plasma at that velocity was a projectile as much as a weapon of heat. But the first test had been conservative. 3 seconds. 2,700 degrees. 1 round. Ryan needed to see what the weapon could do at full specifications before calling the project a success. He ordered the targets removed from the tunnel. The previous shot had demonstrated that striking a solid object scattered plasma into the tunnel walls, punching holes in the concrete lining. Firing at full power through targets would tear the tunnel apart. The technicians cleared the debris while Ryan ran another full diagnostic on the cannon. No damage. No degradation. Every component had performed within specification during the first discharge. The weapon was ready for round 2. At 2 a.m., with the tunnel empty and the team back in the control room, Ryan fired the cannon at maximum settings. Asterisk charge time, 6.7 seconds. Plasma temperature, 3600 degrees Fahrenheit. 1 round asterisk. The discharge was categorically different from the first test. The light was brighter. The sound was deeper. The building shook harder. The recoil platform traveled a full foot backward before the dampeners arrested it. The plasma bolt entered the empty tunnel and flew. Sensors embedded in the tunnel walls at 50-meter intervals tracked its progress. The data painted a clear picture. In atmospheric conditions, energy dissipation was severe. By 500 meters, the bolt had lost the majority of its destructive potential. The remaining energy was sufficient to maintain the bolt's coherent structure but not enough to vaporize targets. By the time the bolt reached the tunnel's end at 3 kilometers, it had expended everything and dissipated into heat and light. Atmospheric energy loss was a known limitation. Ryan had expected it. The solution would come later: improved focusing lens geometry, higher density plasma generation, or deployment in vacuum, space-based applications where atmospheric drag didn't exist. For now, the weapon worked. It fired. It hit. It destroyed everything within its effective range. At 5 a.m., the sky was turning grey. Ryan sent everyone to bed. Rest today. Full day off. Back to work tomorrow. He downloaded the test data to 2 portable drives. One for himself, one for Thornton. The lab's computers were wiped clean. He locked the facility, walked back to the residential block, and called Patricia. Both tests successful. Full details in Thornton's report, which will be submitted by end of day tomorrow. He yawned into the phone. Get some sleep, Patricia said. Planning on it. He hung up and collapsed onto his bed. Patricia sat alone in her office, the desk lamp the only light. She'd been awake since hearing the first test's muffled boom through the facility walls. She'd guessed what it meant and returned to her office to wait. 2 successful firings. A directed energy weapon that could vaporize concrete and steel at 100 feet. Built by a teenager using $100 million of seed funding that the committee had expected to last 6 months of preliminary research. She'd stopped being surprised by Ryan Mercer approximately 3 surprises ago. Now she operated in a state of permanent readiness for whatever impossible thing he did next. She picked up her secure phone. Latest project: 2 experimental firings conducted tonight. Both successful. Detailed report forthcoming from the project lead. The voice on the other end acknowledged, neutral and professional. Understood. I'll escalate. The call ended. Patricia knew what would happen next. The report would climb the chain. Senior analysts would review it. Meetings would be called. Offices would light up across the country, one by one, as the implications cascaded upward. She turned off her lamp and went to bed. Ryan slept until sunset. 14 hours straight. Kyle woke him by knocking on his door with the persistence of a woodpecker. What? Ryan opened the door looking like he'd been dragged from the bottom of a lake. Kyle was vibrating with energy. The firefighting mech model is ready for its mobility test. Do you want to come see? Ryan rubbed his face. The walking test? Already. The professors have been working on it non-stop. It's ready. Give me 10 minutes. He washed up, dressed, and followed Kyle to the mech storage hangar. The building had been expanded recently to accommodate a second machine, and when Ryan walked in, he saw why. Scrapper stood in its usual position on the left side of the hangar. Black, familiar, dormant. Beside it, surrounded by scaffolding, stood something new. The firefighting mech was visibly different from Scrapper in every way that mattered. Where Scrapper was broad and heavy, built for power and impact, this machine was lean and purposeful. Where Scrapper had 2 legs, this one had 4, distributed around a circular rail system at the hip that allowed each leg to reposition independently. Each foot carried a vertically mounted circular saw blade that could raise and lower, designed to cut through forest debris and fallen structures. The cockpit was mounted in the chest, a 360-degree glass enclosure made from fire-rated transparent panels, giving the pilot unobstructed visibility in every direction. No blind spots. No reliance on cameras or radar. Direct visual contact with the fire environment. Above the cockpit, the body showed clear Scrapper DNA in its joint design and frame construction. The transmission model, the actuator placement, the structural geometry. The professors had built on what they knew and added what the mission required. It wasn't finished. It was a test model, skeletal in places, with exposed cabling and unpainted surfaces. But it was standing on its own 4 legs, held upright by its own balance system, looking like something that could walk into a forest fire and walk back out. Professor Marsh approached, smiling. "What do you think?" Ryan looked at it for a long time. The first mech in the world that he hadn't designed. Built by a team of 25 professors and 15 research assistants using technology they'd learned from Scrapper, applied to a problem he'd given them, in a form they'd invented themselves. The second mech on Earth. "Is the structural integrity verified?" he asked. "Calculated, tested, and recalculated. This is the best model we've produced. The frame can handle full operational loads at the design weight." Ryan nodded slowly. "Let's see it walk." Chapter 80, The Firefighter. Ryan stared at the 4 legs. They were hard to ignore. Marsh read his expression and explained before he could ask. The legs serve a dual purpose. In transit mode, the 2 pairs merge into standard bipedal legs using an interlocking joint system. The mech walks on 2 legs like Scrapper. When it reaches the fire zone, the legs split apart. Each pair separates into 2 independent limbs, and the mech lowers itself into a stable 4-point platform. "A platform," Ryan repeated. "That's the core concept. We rethought the role. Instead of a firefighting robot that fights fires, it's a mobile fortress that carries firefighters into the fire and protects them while they work." Marsh walked Ryan through the design philosophy. In a forest fire, the terrain was the enemy as much as the flames. Standard fire engines couldn't reach the fire line. Firefighters advanced on foot, dragging hoses and equipment through brush, smoke, and heat. When the wind shifted and the fire turned, they had seconds to find shelter or die. The firefighting mech solved both problems. In bipedal mode, it traversed terrain that no wheeled vehicle could reach, using its legs to step over obstacles, ford streams, and push through undergrowth. At the fire's edge, it transformed into its 4-legged platform configuration, a stable, fire-resistant base of operations that could hold its ground in the middle of a blaze. "The cockpit seats 1 pilot and up to 9 crew," Marsh said, pointing to the 360-degree glass enclosure. "Fire-rated transparent panels on all 4 sides. The pilot has unobstructed visual contact with the surrounding environment. No blind spots. The crew enters and exits through an internal ladder that drops down from the hip joint. In platform mode, the ladder extends to ground level. In an emergency, the crew retreats inside, the ladder retracts, and the mech's thermal protection system seals them in." Ryan looked at the legs more carefully. Each one had visible mounting hardware for external equipment. "Water storage," Marsh confirmed. 4 tanks on the lower legs, 4 smaller tanks at the waist. Total capacity, 26 tons of fire suppressant. The waist tanks can transfer their contents to the leg tanks via internal rails before the mech enters platform mode, lowering the center of gravity and adding structural rigidity to the support frame. And in platform mode, the mech deploys stabilizer struts from the hip to handle the load, Ryan guessed. "Exactly." Marsh looked pleased. "You can see the strut housings here." He unfolded a structural diagram and handed it to Ryan. The design was more sophisticated than the exterior suggested. The mech wasn't just a walking water tank. It was a complete firefighting system. 3 high-capacity water pumps fed 3 outlets, 1 in each hand and 1 mounted on the back. Combined output, 5,000 liters per minute. Maximum range, nearly 300 feet. At full flow, the mech could empty its entire 26-ton water supply in 6 minutes. A dedicated intake pump could refill the tanks from any natural water source in under 40 minutes. The wrist assemblies carried cable hoists capable of lifting and swapping the leg-mounted water tanks, allowing rapid replenishment at a forward supply point. Roll up, detach empty tanks, attach full ones, return to the fire line. The thermal protection system used high silica fabric over the entire exterior surface, the same material family as professional firefighting suits, rated for sustained operation at 1,800 degrees Fahrenheit. Cooling nozzles distributed across the hull could spray water from the internal tanks onto the mech's own surface, providing active temperature management. Beneath the thermal layer, an insulation barrier protected the internal systems and crew compartment. The circular saw blades on the feet served a tactical purpose, clearing debris, cutting through fallen trees, creating fire breaks. In platform mode, they could be lowered to ground level and operated remotely. "So it's a mech," a fire engine, a crane, and a bulldozer, Ryan said. In a mech-shaped package, Marsh agreed. The forest fire scenarios we modeled showed the highest casualty rates occurring when wind shifts trapped crews in the fire zone. This machine eliminates that. The crew operates from inside the mech's protection envelope. When conditions deteriorate, they pull back inside, seal the cockpit, and the mech walks them out. Ryan studied the structural diagram for another minute, then set it down. Center of gravity in platform mode. With the waste tanks transferred to the legs, the upper body is lighter, but the cockpit with 9 people adds variable load. How does the balance system handle crew movement inside the cabin? Marsh nodded. Good question. The platform mode includes a dynamic balance system derived from Scrapper's gyroscopic mount. It compensates for internal load shifts in real time. We tested it with simulated crew weight and got stable readings across all scenarios. Ryan was genuinely impressed. The professors had taken Scrapper's technology, understood its principles, and applied them creatively to a completely different mission. The mech in front of him wasn't a copy of Scrapper. It was a new machine, designed by people who'd learned to think like mech engineers. Over by the scaffolding, the first activation was beginning. One of the Peterson triplets climbed the internal ladder and settled into the cockpit. The neural link gear was Scrapper's, temporarily transplanted for the test. The firefighting mech didn't have its own neural link installation yet. Ready, the pilot's voice came through the intercom. Start the sequence, Marsh said. The pilot worked through the startup procedure. This cockpit didn't have Scrapper's holographic display. It used mechanical switches and touch screens, functional and unglamorous. The kind of interface you could operate while wearing firefighting gloves. The reactor hummed to life. Systems came online one by one. Status indicators lit up across the cockpit's instrument panels. The mech powered up. And the first thing Ryan noticed was the emergency light bar mounted on the top of the cockpit, strobing red and white in an alternating pattern that screamed fire truck louder than any siren could. Really? Ryan said, looking at the flashing lights. Marsh grinned. The fire department consultants insisted. If it's going to a fire, it needs emergency lights. Regulations. Ryan looked at the world's second mech, standing in a hangar, neural linked to a pilot, powered by a plasma reactor, armored in fire-resistant fabric, carrying 26 tons of water on its legs, with 4 circular saws on its feet and a 360-degree glass cockpit. And flashing emergency lights on top. Fair enough, he said. Chapter 81, Long Legs. The emergency lights painted the hangar red. 40 people squinted against the strobing glare, looking like they were standing in front of a fire truck at point-blank range. Marsh coughed. Kill the lights. Third button on the left. The pilot found the control and the strobing stopped. The hangar returned to normal lighting. The emergency lights are for location visibility in active fire zones, Marsh explained to the group. He turned back to the intercom. Switch to bipedal mode. The Peterson triplet acknowledged and worked through the transformation sequence. The 4 legs folded inward in a coordinated motion. Joint assemblies rotated. The paired limbs interlocked at their connection points and merged into 2 consolidated legs. The feet reformed as well, each one expanding into a pedal pattern splay of 5 broad digits that could flex individually to conform to uneven terrain. Ryan watched the mech's neural link operate with professional interest. The system was a stripped-down version of Scrapper's full architecture. He could tell from the external indicators that it supported only a limited command set, basic locomotion, a handful of emergency reflexes, and a few hard-coded safety responses. Everything else required manual input through the cockpit's mechanical switches and touch screens. That was by design. Full neural control for every function would have driven costs through the roof and increased pilot training time significantly. The hybrid approach, neural for movement and manual for equipment operation, matched how actual firefighters already worked. A firefighter's muscle memory drove the body. Their hands operated the tools. The mech followed the same principle. In bipedal configuration, the machine looked almost normal. Not quite Scrapper's level of presence, but unmistakably a mech. The legs were bulkier than proportional, thickened by the interlocking joint system and the equipment mounts. When the water tanks were installed on the lower legs, the mass would only increase. The scaffolding was rolled away. Take a step, Marsh said. Thud. The mech's first stride landed heavily. Slower than Scrapper, with a shorter gait, maybe 10 feet per step. But it was standing. Moving. following the pilot's input without collapsing, jerking, or losing balance. The second step followed. The third. The mech walked across the hangar floor, each footfall rattling the tools on the workbenches, and reached the hangar door without incident. Ryan clapped. So did everyone else. The professors were grinning. The research assistants looked like they might cry. Kyle stood beside Ryan, hand pressed over his heart. I really thought it was going to fall over, he whispered. Me too, Ryan said, mostly lying. You think so? The structural strength looked marginal in the design review. There was a real chance a joint would fail under dynamic load. You and your team are going to be the first professional mech designers in the country, by the way. At this rate, you'll be the people writing the safety standards for the whole industry. Kyle's face lit up. My parents are going to lose their minds. Marsh continued through the test sequence. Exit the hangar. Run the mobility test on the external field. The mech walked out through the doors. Outside, the training field was a packed earth lot about the size of a high school athletic field, enclosed by a 50-foot perimeter wall. Full darkness by now. The mech's head-mounted spotlight activated, casting a bright cone forward. Then the Peterson triplet opened it up. The engine spun to full power. The legs extended. The mech ran. It wasn't scrapper fast. But it was fast. Two massive legs stretching across the field in long strides, each one covering 20 feet at a time, the ground shaking with every impact. In the dark, lit only by its own spotlight, the machine looked genuinely mythological. Those were, by any reasonable metric, the longest legs currently on planet Earth. Only Scrapper could match them. The sound reached the Neural Link research facility next door. The drift researchers didn't look up. A mech running around at night was no longer a novel occurrence. They had data to analyze. Ryan pulled out his phone and took a photo. The shot was almost entirely dark. The only illumination came from the mech's spotlight and the faint glow reflecting off the ground. The legs were clearly visible, bright against the surrounding blackness. The upper body was barely more than a silhouette. Classified grade image quality. Perfect. A few minutes into the run, the pilot's voice cut through the intercom. Warning light. Something's deforming. System is flagging a structural issue. The team went tense. Slow down. Slow down carefully, Marsh ordered, his voice unusually sharp. The mech reduced speed, each stride shortening gradually until it transitioned from a sprint to a jog to a walk. It returned to the hangar without incident. The warning turned out to be minor. A structural stress indicator had exceeded its threshold during the high-speed run, but no actual failure had occurred. A joint somewhere had flexed further than its design tolerance under dynamic load. The mech was safe to park and inspect. Ryan wasn't surprised. Scrapper's first walking tests had produced similar warnings, and he'd been working from perfect blueprints. These professors and students had designed this machine from scratch, using first-generation principles on a second-generation mission profile. That they'd gotten it this close to working on the first full test was impressive. Structural team, you're up, Ryan told the group. You're about to have a very busy week. Kyle relaxed noticeably. Structural issues weren't his problem. He did have a problem, though. He was the lead on the Neural Link team, and the moment the Peterson triplet climbed down from the cockpit, Kyle and the rest of the Neural team descended on him to ask about the connection experience. Meanwhile, Marsh and the other professors were already scaling the scaffolding with their diagnostic equipment, heading for the cockpit to pull logs and inspect the flagged joint. Ryan looked around. Everyone had work to do. He did not, at least not right now. He cleared his throat discreetly and left. He was hungry. He'd been hungry since he woke up. 14 hours of sleep had taken his stomach to a desperate place. The 24-hour cafeteria was open. He ordered a light noodle soup, sat at a corner table, and pulled up the photo he'd taken. Good shot. Mysterious. Atmospheric. The upper body of the mech was barely visible. He added a little more digital obscurity to the upper half, just enough to make sure no one could reverse engineer the design from the image. Then he opened Twitter. Asterisk saw this on the field tonight during my run. Is this what people mean by long legs? Pretty sure nothing else on Earth has legs this long asterisk. He attached the photo and hit post. His soup arrived. He ate it slowly, watching the engagement numbers climb. Chapter 82, The Real Productivity. Within 30 seconds of posting, the comments started rolling in. What am I even looking at? I came here for the long legs. I thought it was going to be a cryptid. I was ready to go cryptid hunting. This is clearly a mech leg. The rest of the photo is just darkness. So this is the new mech you're working on? Ryan, slurping noodles, typed a one-handed reply, asterisk not mine. My team built this one. Asterisk. The comments pivoted instantly. I knew it, but hearing him confirm that he runs a whole research team at 14 still makes me want to sit in a corner. Why are my eyes wet? Oh right. Because I'm eating lemons. What do I need to do to join your team? Would you accept a graduate student? Ryan didn't reply to the rest. He finished his noodles and opened the system panel to check progress. Project 2, 79%. He stared at the number. Last time he'd checked, it had been at 68%. 11 points in just over a week. That wasn't normal progress. Summon points accumulated gradually based on how often his name got said. 11% in a week meant his name was being mentioned at roughly 3 times the normal rate. Something had happened. Ryan pulled up the Harvard prosthetic video Chloe had mentioned. The one from the Whitfield lab, now backed by Helios Group. He found the top repost on the domestic platform. The comment section was a war zone. Harvard's technology is objectively better, but I guess the fanboys can't handle facts. Paid trolls funded by foreign money. Your chat logs got leaked. Just because you can't accept that your idol is behind doesn't make it a conspiracy. The Whitfield lab is already backed by Helios. They'll be on the market before Mercer even finishes his first working model. Ryan Mercer was smart enough to run mechs. He should have stayed in his lane. He's getting demolished in this one. The fight rolled through every ideological flavor imaginable. Nationalism, science worship, brand loyalty, political affiliations. Comment thread arguments that started with "the technology is better" ended with "your mother ate" replies deep. The linguistic creativity was genuinely impressive. Ryan checked other places. The battles were everywhere. Every discussion about him, every video involving mechs or prosthetics, every adjacent topic. The same patterns. The same language. The same coordinated hostility wearing slightly different masks. This wasn't organic criticism. This was a paid campaign. If it had been anyone else, the coordinated smear would have been infuriating. But Ryan wasn't anyone else. Ryan had a system that converted every mention of his name into research progress, and the system didn't care about sentiment. A million people yelling that he was a fraud generated the same points as a million people calling him a genius. His appetite doubled. 2 more bowls, please, he called to the cafeteria staff. Those trolls weren't hurting him. They were his workforce. The most productive people on the internet right now, doing hundreds of thousands of dollars worth of R&D labor without knowing it. Ryan had always believed that haters were undervalued in the broader economy. Now he had proof. If he ever led humanity to the stars, the monument wouldn't just bear his name. It would list every troll who'd ever called him a fraud in a comment section. They deserved the recognition. They'd earned it. He returned to his own post. The trolls had arrived there too, already tangled with the regulars in a fresh round of combat. Ryan watched the engagement numbers climb while he ate. His phone rang. Tom. Dad. Do you know what's happening online? Tom's voice was tight. The coordinated troll campaign? Yes, just noticed. How are we going to respond? Do you have people who can push back on this? Content moderation, account takedowns, something. No. Ryan. This looks like it's coming from Helios Group. They've invested heavily in Whitfield's lab and they're treating us as a competitor. This is a market warfare operation. They're trying to poison our brand before we launch. Probably. Then we have to do something. Ryan slurped another bite of noodles. Dad. I'm not worried about the market. You should be. A coordinated smear campaign from a company with Helios-level resources could ruin us before we sell a single unit. What's their R&D budget for the Whitfield lab? Tom paused. I've seen the numbers. Hundreds of millions already, and they're projecting several hundred million more to reach production. And what's our R&D spend to date on Prism Sciences? Tom pulled up the ledger. He ran a company. He had the numbers at his fingertips. Including your neural link hardware, the sensor cap fabrication, Mason's team's salaries, and the materials acquisitions, we've spent about $500,000. 500,000. 500,000. Ryan let that hang in the air. Our first generation product is going to be ready for production at under 10 million in total R&D cost. Their product is going to market at a price that reflects several hundred million in development. We'll undercut them by an order of magnitude at launch. But if nobody trusts our brand, price won't matter. Their product also requires targeted muscle reinnervation surgery to use. It's a prerequisite. Nerve transplantation, months of recovery, surgical complications, and a permanent physical modification that can't be reversed. Our product doesn't require surgery. The user puts on a sensor cap and operates a prosthetic. That's it. And no amount of troll farming changes that. When the products go head-to-head, a non-invasive device at a fraction of the price is going to crush a surgical solution at premium pricing. Helios knows it. That's why they're attacking us now, before we can launch. They're buying time with paid engagement because they can't buy time with their technology. Tom was quiet for a long moment. You really aren't worried? I'm delighted. The more they talk about me, the faster my research goes. Your research goes faster when people argue about you. Something like that. Ryan didn't elaborate. The system was not a topic for phone conversations. Tom exhaled. Some of the tension left his voice. Fine. But we still need to finish the first generation product. The longer it takes, the more damage they can do. It'll be ready soon. You said that yesterday. And I'll say it tomorrow, and the day after, and then one day I'll say it's ready instead. I hope that day comes before my hair falls out. I make no promises about your hair, Dad. Tom laughed despite himself and hung up. Ryan turned back to his noodles. The bowl was cold. He ordered a third one and settled in to watch the trolls generate summon points on his behalf. The real productivity, he thought, was finally arriving. Chapter 83, The Eunuch Worries More Than the Emperor. The money was coming soon. The $100 million plasma cannon bonus. Ryan wasn't sure exactly how much the cannon's fabrication had cost. But he was certain it had come in under budget. The research process had been nearly zero cost, no wrong turns, no failed prototypes, no wasted iterations. The only real expense beyond materials had been Thornton's team's salaries. If that alone was enough to blow the budget, it meant Thornton was overpaid. Tom absorbed this. Your end has a bonus coming. About 100 million. Tom went quiet for several seconds. He'd learned to accept numbers from Ryan the way a surfer accepted waves. You didn't fight them, you just found your balance. I'll take your word for it. Mason's team has some big purchases coming up. Let me know when it hits. Tom handed the phone to Lisa, who chatted for a few minutes about the weather, Tom's diner project, apparently he was going to publish his chicken fried steak rankings, and a distant cousin's wedding. The normal family talk that Ryan had been missing without realizing it. When the call ended, Ryan finished both bowls of noodles and left the cafeteria. Walking back along the gravel path, he texted Patricia. When does the bonus come through? The reply came in under 30 seconds. 2 days. Need a new bank account? Send it to my dad. I don't care about the money. The reply was just the ellipsis. Patricia, who had seen a lot of billionaires in her career, had apparently given up reacting to Ryan's relationship with money. It wasn't an affectation. A year ago, $100 million would have been life-changing. Now it was a budget line. At this rate, he'd be at $1 billion before his voice finished changing. The numbers had stopped meaning anything. Back in his quarters, Ryan dropped his phone on the desk and was about to open the Crimson Typhoon database when he saw a second message from Patricia, sent 2 minutes earlier. Just checked your Twitter mentions. Something's off. Let me handle it. His stomach lurched. The trolls. Patricia had found them. Ryan typed fast. Leave them alone. Economy is bad this year. Let them earn their paychecks. It's the least I can do. Patricia's reply was another ellipsis. He shrugged. The trolls were doing important work. Their progress contribution to the system was measurable in real time. But Patricia was Patricia, and if she decided to act, she would act. The troll farms were operating on borrowed time. Ryan mourned them briefly and moved on. He opened the system and pulled up Crimson Typhoon's shock absorption system. This was the technology he'd been forcing himself not to study since it had unlocked during the chairman call. Now that the plasma cannon test was complete and the firefighting mech mobility test had proven the team's competence, he could finally dig in. The damper system was extraordinary. For a machine the size of Crimson Typhoon, vibration management wasn't a comfort feature. It was a survival system. Every footfall of a 1,700-ton machine generated shock loads that would shake a lesser vehicle apart. Multiply that by running speeds. Add combat impacts. Add wave strikes from deep ocean deployment. Add the occasional fall from height. Without an elite damper system, the mech's internal components would disintegrate within weeks of operation. Crimson Typhoon's solution layered multiple technologies. Achilles dampers in the feet absorbed primary impact energy. Magnetorheological fluid dampers in the leg joints handled secondary resonance. A distributed network of inertial absorbers throughout the frame managed high-frequency vibration. The systems worked in concert, each covering a different energy band, collectively reducing shock transmission to the internal structure by over 90%. And it wasn't just protective. It was active. The magnetorheological dampers could modulate their stiffness in real time, stiffening to absorb hard impacts or softening to allow rapid joint motion during acrobatic maneuvers. This was the technology that let Crimson Typhoon perform combat moves no other Jaeger could execute. Ryan studied the architecture for hours. The engineering was layered deep enough that he kept finding new details to appreciate: a cross-connected bleed valve that redistributed pressure across the leg during asymmetric loading, a secondary inertial reference frame that isolated the cockpit from the main hull's oscillations, a torque decoupling mechanism in the shoulder joint that let the arm move without transmitting reaction forces to the torso. Pieces of this system would revolutionize multiple industries on their own. Aerospace shock isolation. High-rise earthquake damping. Precision manufacturing vibration control. A single researcher who fully understood this damper architecture could build a career spanning the rest of their life. At 11 p.m., Ryan forced himself to close the database and go to sleep. The next morning, he visited the weapons lab. The atmosphere was different. No exhausted faces. No post-adrenaline crash. The team was vibrating with the specific energy of people who'd just accomplished something they'd spent their lives trying to do and hadn't slept because they couldn't stop talking about it. Thornton was at his desk, writing. His face showed fatigue, but his eyes were bright. "Sleep at all?" Ryan asked. Thornton yawned in answer. "Enough. Finished the results report." He handed Ryan a portable drive. "You probably don't need this, but procedurally, you get one." The gesture was deliberate. Thornton was treating Ryan as a superior, not a peer. The senior researcher on a classified weapons program formally reporting to a 15-year-old. If Ryan had been capable of being moved by institutional recognition, he might have been. "Thank you. One more thing. Once we finish the baseline testing cycle, we may be relocating." Ryan raised his eyebrows. "Already? This facility is practically new." Thornton laughed ruefully. "Nobody predicted the project would move this fast. A dedicated facility is being constructed on an accelerated timeline. By the time the basic tests are finished, the new site should be ready. I guess the next research center will get more careful planning." "I'd imagine so." They shook hands. The gesture was mutual, two people who'd done good work together and expected to do more in the future. Thornton walked Ryan to the door and went back to his report. No tests were scheduled for today. The cannon was being disassembled for component inspection, measuring wear patterns, identifying stress points, projecting the weapon's operational life. Ryan watched from a safe distance and opened the Prism Sciences group chat on his phone. "Mason, list every technical problem your team has encountered in the last 2 weeks. Drop them in the chat." The messages started coming in. Drive system efficiency issues. Finger articulation timing conflicts. Thermal management in the wrist actuator housing. Power draw optimization for the onboard computer. A dozen specific engineering problems that Mason's team had been wrestling with. Ryan worked through them one by one, typing corrections, sketching solutions, flagging misconceptions. 2 hours of remote consultation compressed into rapid-fire technical answers. By the time he was done, Mason's team had clear direction on every outstanding issue. Viv sent the last message. "Ryan, the Whitfield prosthetic that Helios is backing. There's news that they're preparing to launch. They're building direct-to-consumer fitting centers already." Chapter 84, The Helios Plan. Why would them opening fitting centers be a problem? Someone in the chat got there before Ryan could. Viv forwarded a news link. The Helios CEO said they're going to expand their fitting centers globally, including into our domestic market. Prosthetic limbs couldn't be attached directly to the human body. Every amputation left a residual limb with unique contours, scar tissue, and bone structure. Connecting a prosthetic required a custom-fitted socket, a device called a residual limb interface, which had to be individually molded to the wearer's anatomy. This was what fitting centers did: they measured the residual limb, produced a resin or silicone socket, and attached the prosthetic to it. The socket's quality directly determined whether the prosthetic was usable or tortuous. A badly fitted socket meant pain, skin breakdown, and abandonment of the device. A well-fitted socket meant the prosthetic could be worn all day. Fitting centers didn't manufacture prosthetics. They distributed them. They had hospital relationships, referral networks, and regional footholds. Most prosthetic manufacturers sold through these third-party networks rather than operating their own retail footprint. Helios, apparently, was going direct. The team was alarmed. They're entering the domestic market already. Their Harvard tech is mature enough for consumer launch. Can our prototype even compete with their product? They have tactile feedback. We don't even have that on the roadmap. Ryan read the chat with a flat expression. A team of recent graduates, all of whom had spent their academic careers on myoelectric prosthetics, were panicking about a competitor's neural prosthetic launch while completely failing to recognize that their own product was technologically superior to the competitors in every meaningful dimension. At least Mason was holding it together. Being the team leader meant staying calm. Ryan, what do we do? Ryan sighed. Mason had lasted 3 minutes before joining the panic. All of you, go read the technical specifications of Whitfield's prosthetic. Actually read them. Understand what his product requires. Then come back and tell me why you're worried. The chat went silent. Nobody wanted to admit they didn't already have the information they should have. Ryan put his phone down and went back to watching Thornton's team disassemble the plasma cannon. Meanwhile, in a glass-walled conference room overlooking a harbor 3,000 miles away, the Helios Group's senior leadership was meeting. At the head of the table sat Michael Reeve, the CEO. Tall, silver-templed, the kind of man whose suit fit him the way paint fit a canvas, unobtrusive, professional, expensive without being showy. Beside him sat his chief operating officer and 2 senior assistants. Across the table, Whitfield and Osman represented the Harvard partnership. Reeve stood to begin. Everyone, good to see you. First, I want to congratulate us on completing Phase 1 successfully. He clicked a remote. The screen behind him displayed engagement metrics. Ryan Mercer's name had seen a 60% increase in negative sentiment coverage over the past 2 weeks. Whitfield's lab had become the dominant reference point in discussions about neural prosthetics. The narrative shift was measurable. We have successfully pivoted public attention away from the Mercer project and toward our technology. Millions of people are now looking to us as the leaders in this space. That's the foundation we needed. Now we build on it. Whitfield shifted in his seat. He was a scientist. Discussions of narrative pivots made him uncomfortable. Reeve continued. Phase 2 is commercial launch. We're creating a dedicated subsidiary to manage the neural prosthetics product line. The brand name, tentatively, is Angel. The positioning is simple: our product gives people their lives back. The name reflects that. The screen changed. A clean, ivory-toned logo with stylized wings. Minimalist. Premium. Pharmaceutical adjacent. It looked expensive. It was supposed to. We're establishing fitting centers globally. Priority markets first, but we're planning domestic and international expansion in parallel. Fitting centers will be company-owned and operated, not third-party licensed. Whitfield raised a hand. He didn't like this part. I'd recommend against international expansion at this stage. The regulatory and logistical complexity is significant. We should focus on proving the model in one market before scaling. Reeve shook his head politely. Professor Whitfield, with respect, you're thinking like a scientist. The math of this venture doesn't work on a single market basis. He leaned forward. Your lab has absorbed approximately $300 million in research funding over the past decade. Helios is committing an additional $700 million in productization costs. That's $1 billion initial investment before a single unit ships. Factories, fitting centers, regulatory approvals, training programs, ongoing R&D. The total all-in cost to reach market at the scale we're planning is closer to $2 billion. Whitfield's mouth tightened. I'll be direct. At normal operating margins, this product will not recoup its investment for 15 to 20 years. The addressable market for brain-controlled prosthetics requiring targeted muscle reinnervation surgery is limited. The product will never be cheap enough for mass adoption. In a pure profit and loss analysis, Angel is a money pit. Whitfield closed his eyes. He already knew this. He'd been living with this knowledge his entire career. Which is why, Reeve continued, his voice rising, we're not going to operate Angel as a profit center. The room leaned in. Angel is not a product. It is a narrative. Helios Group is the technology company that is saving disabled people. Helios Group is the company that combines cutting-edge science with compassionate application. Every fitting center we open becomes a permanent billboard in a major city. Every prosthetic we fit becomes a marketing asset with a face and a name. Every story we tell becomes press coverage, brand elevation, and public trust. The screen showed a map of proposed fitting center locations. Dozens. Not a distribution network. A brand campaign. The fitting centers will welcome visitors regardless of whether they need a prosthetic. They will be showrooms for our technology. They will host community events, school tours, media segments. They will become the places people associate with Helios Group's commitment to humanity. Reeves' coo caught his gaze. They'd had this conversation. She knew where this was going. And here's the financial mechanism, Reeves said. Angel's success as a brand, its cultural positioning as the company making the future accessible, will drive a valuation premium across our entire portfolio. When we launch the next Helios funding round, we will not be raising money as a tech conglomerate. We will be raising money as the tech conglomerate that is fundamentally reshaping human capability. That shift in narrative will add billions to our valuation. Billions, not millions. The direct losses on Angel's operations will be completely swallowed by the equity uplift. Whitfield stared at the table. He'd come into this meeting expecting a product launch. He was leaving it having been told his life's work was a marketing prop. Osman, seated beside him, didn't look surprised. He'd spent enough time in industry to recognize the play. Reeve concluded. Phase 3 is the funding round. When Angel has its first 6 months of public operation, when the brand is established, we launch. That's when the real money arrives. The coup, silent throughout, understood completely. Her boss was a genius. He was going to sell his story 3 ways: narrative capture of the neural prosthetics space, technology absorption from Whitfield's lab, and billions in valuation uplift at the next round. 4 meals from one fish. Angel was never meant to save disabled people. It was meant to save Helios Group. Chapter 85, Holding Their Breath. After the plasma cannon test, Ryan's schedule eased. Most days he reviewed the drift data, checked on the cannon's disassembly analysis, and ran remote troubleshooting for Kyle's firefighting mech team. The structural failure flagged during the mobility test had been confirmed as load-induced deformation. The team was substituting a higher-grade alloy for the failed component and running validation tests. The rest of his time went into the damper system research. The deeper he studied it, the more there was to find. Then Mason called. The new arm is ready. Can you come review? Ryan got in the SUV and rode to the Prism Sciences workshop. The hand-painted sign on the metal gate was still there. Prism Neural Prosthetics Research Center still looked like a converted textile workshop. Because it was. Mason met him at the door, visibly more confident than the last time Ryan had visited. Full structural redesign. All parts 3D printed, assembly is in progress right now. Inside, the team was gathered around the central workbench. They looked at Ryan with expressions that mixed sheepishness and determination. He'd sent them to study Whitfield's technical specifications, and they'd clearly done their homework. The panic from 2 weeks ago was gone, replaced by something that looked like hunger. They'd figured out that Whitfield's prosthetic required surgery and theirs didn't. They'd figured out that the competitor's product couldn't touch their price point. They'd figured out that the trolls online were being paid to manufacture fear. And now they wanted payback. The new prosthetic sat on the bench, mid-assembly. Viv was installing the last of the fiber optic control cables. The structural design was a complete rebuild: titanium alloy frame, precision printed joints, a skeletal aesthetic that looked like it had walked out of a cyberpunk movie set. Key components are all titanium printed, Mason explained. Without the battery, total weight is about 4 pounds. Given the complexity of the internal structure, that's extremely light. Viv tightened the last screw and sealed the housing. Ready for testing, she said. One of the technicians plugged in an external power supply and ran a diagnostic on the internal systems. While that was running, Mason continued. Response times are dramatically faster. We've hit near biological reaction speed across all joints. And every finger operates independently now. 10 separate motor channels. The diagnostic cleared. The team activated the prosthetic from the computer, bypassing the neural link for this test and sending motor commands directly to confirm the hardware was functional. The fingers moved. Not like a machine trying to simulate a hand. Like a hand. 10 digits flexing in sequence, then in waves, then in independent patterns. The wrist rotated smoothly through its full range, transitioned into flexion and extension, and returned to neutral. The elbow joint articulated without the hitch and recovery pattern that had characterized the first prototype. Watching it move, you'd never guess it was an artificial limb. It looked like what it was supposed to look like, a fully functional human arm, rendered in metal. Phenomenal progress, Ryan said, meaning it. This team had genuine engineering talent. Given the right direction, they were going to build something remarkable. Then he noticed what was missing. Battery life. What's the runtime outside the lab? The current tests used an external power supply or a brick-sized test battery. Neither was viable for a consumer product. Nobody wanted to walk around with a brick hanging off their arm unless they were going to a fight. Mason scratched his head. Standard prosthetic batteries give users 1 to 2 hours of operation, about a few hundred grip cycles per charge. But our motors are higher powered than the industry standard, and the neural control system adds its own draw. If we use a conventional battery, we're looking at under an hour. Put a standard battery on it. Let's see. Someone ran to the storage room and returned with a 7.4-volt lithium pack, the kind used in most commercial prosthetics. They installed it, connected the neural control module, and started the runtime test. The team watched the prosthetic cycle through continuous movement patterns while the battery discharged. Under 30 minutes. That was the runtime under heavy use. Under light use, maybe an hour. Not enough. The main drains were the motor system and the neural control hardware. The motors could be made more efficient. The neural link was already at the floor of its power consumption envelope. Ryan frowned. We need more battery capacity, even if it adds weight. The plasma reactor wasn't shrinkable to prosthetic scale. The ion batteries were overkill. He'd have to settle for an optimized conventional battery, or accept a bulkier pack that made the arm less elegant but more practical. First-generation product. Short battery life was a known weakness. They'd ship extra packs so users could swap between them. Mason didn't have better options either. His team didn't include anyone with a battery chemistry background. We'll test some alternatives. Higher capacity packs, different form factors. Viv spoke up. She'd been quiet most of the meeting. Ryan, when's the next live test? Are we going to film it again? The rest of the team looked up in unison. Clearly this was a question they'd discussed among themselves. Ryan understood. They'd seen the coordinated trolling online. They'd read the comments calling Prism Sciences a backwater project. They'd watched Angel's launch campaign build momentum while their own product received daily digital insults. They were holding in a collective breath of resentment, and they wanted an outlet. 2 weeks ago, they'd been terrified the competition was going to crush them. Now they knew the competition was a paper tiger. And they wanted to prove it. Ryan checked the calendar. November 15th. Chloe's birthday was coming up. She'd committed to visiting on the 20th. Next live test is on the 20th. Be ready. Chloe would be here to film. The Helios camera crews would never match her work. Ryan was not bothered by the trolls calling his cinematography bad. He was, however, motivated to prove that bad cinematography was a stylistic choice, not a production limitation. Yes. The team's enthusiasm was visible. We'll be ready. We'll be more than ready. Ryan looked at them, slightly confused by the intensity. This was just the next scheduled test. They were acting like it was the championship round. But he didn't push back. Whatever was motivating them, it was producing good work. He'd take it. November 20th. 5 days out. The countdown began. Chapter 86, Filming Day. Ryan left for the train station before sunrise. The ride was quiet. Coastal Road, dawn sky turning from grey to pink, the 2 security personnel in the front seats treating him like freight. Today he was in a regular-looking sedan instead of the tactical SUV. The body panels were still armored. The difference was visual, a low-profile vehicle for a low-profile trip. He reached the station with time to spare. Stood on the platform. Watched the sun crest the horizon and gradually start feeling uncomfortable on his skin. His phone buzzed. Getting off the train. I'm at the exit. Come outside. He stepped out of the station entrance and had barely sent a reply when he heard it. Ryan. Chloe was coming across the plaza at full speed, pink rolling suitcase behind her, a backpack slung over one shoulder, her stride easily covering twice the ground of anyone else on the concourse. She stopped in front of him and immediately reached up to pat the top of his head. You grew. Again. Ryan realized she was right. The months since he'd last seen her had added another inch or two. Chloe had been slightly taller than him all through childhood. Now she had to tilt her head down to look him in the eye. Let's get in the car. The sedan pulled away from the curb. Chloe sat beside Ryan in the back seat, immediately unzipping her backpack and pulling out a small camera to check its battery and card. We're going straight to the research center. She asked, looking out the window like a kid on a field trip. It's not far from my facility. We'll shoot the test, then head back for dinner. I told them to save us drumsticks. Chloe nodded approvingly and kept inventorying her equipment. She'd brought 4 cameras of varying sizes, a lens kit, a small lighting rig, and a pocket-sized audio recorder. The woman had come prepared. The sedan pulled up to the Prism Sciences workshop. Chloe stepped out, looked at the building, and stopped mid-stride. This is it. This is it. She walked up to the metal gate and flicked one of the painted letters on the sign. It didn't fall off, but it looked like it had considered the option. Ryan shrugged. The mountain isn't great because it's tall. The mountain is great because a sage lives on it. You're quoting poetry at me now. Shallow water, deep dragon. Don't let the exterior fool you. When the first generation product launches, this place becomes a landmark. You're so full of it. Fine. The real reason is that we don't have enough money for a nicer building. Once I get Dad's next funding round together, we'll break ground on something proper. Chloe patted him on the shoulder. Progress. You're finally admitting to budget constraints. Mason opened the door. His eyes tracked Chloe with the confused expression of a man who was not expecting to see a pretty college student walk into his workshop. This is my camera operator. She's filming today. Ah. Right. Of course. Mason caught the look on Ryan's face and quickly steered the conversation away from whatever he'd been about to say. Come in, come in. Everyone's ready. Inside, the team had set up for the test. Grant was seated in the test chair with Danny beside him. The new prosthetic was on its support stand. Cables and connectors were arranged on the bench. Chloe didn't waste a minute. She opened her bags, pulled out 4 cameras, and started setting up angles. One locked on Grant's face for reaction coverage. One on the prosthetic for movement isolation. One wide on the whole room for context. One handheld for her own use, floating between subjects as needed. Within 15 minutes, she had a multi-camera setup that would have been standard on any broadcast production. The team watched with the relief of people who'd been dreading another round of shaky static camera footage. Ryan's last test video had become a minor meme for its classified grade cinematography. They did not want a repeat. Grant looked more relaxed this time. Several media outlets had contacted him since the first video went viral, offering small appearance fees for interviews about his experience as a test subject. The money had genuinely improved his family's situation. Danny, his son, looked less anxious than before, more engaged, occasionally smiling. Chloe gave the go signal. The team moved. A technician fitted the sensor cap onto Grant's head. Connected the signal converter. Linked it to the prosthetic. Ran the system diagnostic. Green across the board. Ryan settled at the monitoring station. Mason approached him quietly. Should we have someone narrate the technology this time? Like the Whitfield video? To compete on the educational angle. Ryan shook his head. Save that for the product launch. Until then, let them speculate. He turned to Grant. Start with the 3 movements we nailed last time. Got it. Grant closed his eyes, focused. The prosthetic responded instantly. Fist closed. Wrist rotated. Elbow flexed. Each motion executed smoothly, without the hesitation that had marked the first session. Ryan gave a thumbs up. Now try all three simultaneously. Grant concentrated. The prosthetic responded. The fingers closed into a fist while the wrist rotated and the elbow flexed, all three motions executing in parallel without any delay between them. The hand moved like a hand. Not a sequence of mechanical responses. An actual, coordinated limb performing multiple movements at once. Applause from the team. Now for the hard part. Ryan kept his voice level. Individual finger control. Grant nodded. He knew this was the test that mattered. 5 individual neural signals had to be isolated, decoded, and mapped. The room went quiet. Grant stared at the prosthetic, concentrating with the focus of a man trying to remember something he'd forgotten a decade ago. The fingers didn't move. Minutes passed. Sweat beaded on Grant's forehead. Danny handed him a tissue. 30 minutes in, with Grant's shirt now damp with effort, the first breakthrough came. A single click. Clean. Definite. The left thumb of the prosthetic extended and flexed once. The room exhaled. That was the first signal. With one finger mapped, the system had a reference point for isolating the others. The rest would come. It took another 90 minutes. Each finger's neural signature was identified, locked, and integrated into the control system. By the time the fifth finger twitched into action on command, it was late afternoon. Chloe was drenched in sweat from hauling cameras between positions for 4 hours straight. She had enough footage to edit 3 different versions of the test. Dinner, Ryan said. My treat. I thought you were going to say bubble tea. I was. Then I remembered you told me you're training. Chloe pouted theatrically. I appreciate the restraint. We'll hit the cafeteria at the facility. Fresh caught fish, rice, vegetables. Much better than the tea shop. Can I get 2 drumsticks, though? 2. Only 2. 2. Chloe considered this. Fine. But only because you are being very adult about the bubble tea. Back at the tea shop, the owner swatted a fly on the counter with a practiced flick. He looked up in time to see 2 figures walking past his front window without coming in. He recognized them. The same kids who'd talked about $10 million. The same boy who'd walked away without ordering last time. Now they weren't even entering. What is this? He muttered. They're bragging from outside the store now. Remote bragging. Exterior only. He shook his head and went back to wiping the counter.
Additionally, if you would like to request novels and access my Google Drive where I have 200+ audiobooks, then you can join my Patreon. Link is also provided in the description.